Hopefully you remember from geometry that when you want to find the geometric mean of two numbers, you need to set up a proportion. So we're going to do exactly that. So let's just call our geometric mean here x, and the way we set up our proportion is we'll put x in the denominator in one fraction, the numerator in the other fraction, and then the two numbers in the other places. So that's how we're going to find our geometric mean. So we cross multiply, right? Take the cross product. X squared is 3 times 48. X squared is 144. So I know that x, if I take the square root of both sides, if I weren't talking about geometric mean, I would have plus or minus 144. But we know the geometric mean has to be a positive number, so it's not going to be negative. I mean, sorry, it's not 144 either. It's 12. Square root of 144 is 12. So since we're talking about geometric mean, it's going to be positive, and we know it's going to be 12, the square root of 144. All right, I'll do one more of these, then you can do the other. I will do 18, then you can do 17. X, 100, 4. X squared equals 400. So x is going to be the square root of 400, which is 20. So the geometric mean of 104 is 20. All right, and if you do the same procedure here with this one, you're going to have x squared equals 45 times 80, and that is 3,600, so x is going to be 60. So finding the geometric mean, fairly easy thing to do. So now we're going to talk about a geometric series. What does that mean? It means the same thing that it meant when we talked about arithmetic series. It just means we've got a sequence, and now we're going to add the terms of the sequence. So here's our formula. Again, this will be on your formula sheet when you take the SOL test. Will not be given to you when you take this unit test, so you need to know it. But the good news is our calculator will also do this very nicely for us. Let's go through one though where we don't use our calculator, so that in the event something tragic happened and our batteries died, or I was at a party and someone asked me to find the sum of a series and I didn't have a calculator, I could just whip it right out. So here's our formula. We know that the sum of n terms is the first term times the ratio, the constant ratio to the I minus 1 power, or I can use this formula right here if I don't have my calculator. So here we go. What's a sub 1 here? What is the first term? Well, we have to plug 1 in, right? We have to plug in 1 for I. So the first term is going to be 30 times 1/5, and 1 minus 1 is going to be 0, right? So 1/5 to the 0 power, that's 30 times 1, so a sub 1 is 30. My common ratio is 1/5. Because see, I can see how this compares to this formula right here. And n, oh, where do I get n? Right here, right? I'm taking 6 terms. I start with the first term, I end with the 6th term, so that's what the n means, 6. All right, so how do I do that with my formula? The sum of the 6 terms is the first term, 30. And I got to multiply that by 1 minus r. Well, remember r is 1/5. N is 6. And then I have to divide that by 1 minus a fifth. You got to be careful when you're doing this with your calculator. I'm going to punch that into my calculator right now and put the answer here for you. So when I punch all this into my calculator, or do it without a calculator, but whew, that's a terrible calculation. What I get is 23,436 over 625. And if you happen to get a decimal, it comes out to be 37.4976. Now do remember, since I have given you r as a fraction, 1/5, I would want your answer to be a fraction also. So now let me show you how to do this using your wonderful calculator. So what we want to do, remember before when we were finding the sum, is we would go alpha F2, and I want to choose number 2, which is the sum. All right, we're using x as our variable, and we're doing 6 terms, right? So I'm going from 1 to 6. And then if we look back here, let me take a peek back. Here's my formula right here that I've got to put in, well, actually this part here is what has to go into my calculator. A sub 1 times r, and it's going to be to the x minus 1. So a sub 1, what is our a sub 1 here? It's 30. And what is our r here? It's 1/5. So let me go ahead and open my parentheses there. And if you remember from the past, to get our fraction put in there as a fraction, we're going to put alpha y equals, enter, and that's going to set up my fraction. So 1 divided by 5. Of course, you could put 0.2 also, and then you're going to get that decimal. And let me close those parentheses. And what have I got to raise that to? To the, excuse me, to the x minus 1 power. X minus 1. Get out of these parentheses. You got to be a little bit careful with your parentheses, guys. So hit enter, and there is that fraction I got. And just a little refresher, if I did want to change that to a decimal, remember all I got to do is hit math, and I want to come down to number 2 because I want to change that answer I have there to a decimal. Hit enter, and there's my number, 37.4976. Okay, so you got 3 more here. Let me do number 22, and then I will put the answers for 20 and 21 up, and you can pause and work those on your own. All right, this time, look, we got something a little different here in that we're starting with 0. Okay, we're starting with 0. So if we want to figure out what a sub 1 is, when n equals 1, I'm going to say a sub 1. Well, a sub 1 is going to be 10 here. Excuse me. Because if I put 0 in here, I get negative 1/2 to the 0. So that actually... So a sub 1 is 10. R is negative 1/2. But guys, what we have to be aware of here is that since we're starting with 0, we actually have 11 terms here. 0 through 10 is going to give us 11 terms. So when we go to do this by hand, we got to be very careful. So S is going to be 10, and then I'm going to use my formula here that I use when I'm doing it by hand. 1 minus negative 1/2 to the 11th power, because remember we got 11 terms, so I got to put 11 there, and then I got 1 minus negative 1/2 down here on the bottom. All right, and when I multiply all that out, I will end up with 3,415 over 512. I hope I got this correct. Let's go check it with our calculator, and then I'll make sure, we'll be sure whether it's correct or not. Okay, so I'm going to find the sum. So I'm going to go alpha F2, choose number 2 for summation. I'm going, using x as my variable, and remember this time I'm starting at 0, and I'm going to 10. And what do I have? I have 10. And I'm going to open my parentheses. I'm going to use a negative, and then I'm going to come here and get my fraction set up. So I've got negative 1/2, so 1 divided by 2. I'm going to close those parentheses up. And what am I doing? I'm raising that to the x power, not x minus 1 this time. You want to enter it just like it is written on your paper, to the x power. get out of these parentheses and see how much that gives me. And yeah, I do get 3415 over 512. And once again, if you needed to see that as a decimal, which you don't in this case, but just to remind you how, I'm going to hit math and I'm going to choose number 2 and I'm going to hit enter, and there is that sum as a decimal. It's about 6.7. And here are your answers for numbers 20 and 21. The sum will be approximately 1.71, and this sum here is 7,971.61. Of course, both of those are rounded off. You will get the same answer if you do it by hand using this formula, or if you use the summation feature on your calculator. Okay, so these, if I look at these are all finite series, finite geometric series. What does that mean? Well, it means that they don't go on and on forever. There is a last term. Believe it or not, we can actually find the sum of an infinite series. If there is no last term, we can still find the sum, because what's really happening is that the sum is just getting closer and closer and closer to a number. And so the only time we can find a sum of an infinite series, though, is if our ratio is less than 1. If the ratio is greater than or equal to 1, then there is no sum. So before you haul off and start trying to find the sum of an infinite series, first of all, you want to make sure that your ratio is less than 1, because if it isn't, you don't have to trouble yourself. Okay, well, let's see why this works. Let's look at this series here. If we just take the first term, we get a half. If we add the first two terms, what do we got? 2/4 and 1/4, we got 3/4. If we add the first three terms, we got 3/4 plus 1/8. So that's 6/8 plus 1/8, 7/8. If we add the first four terms, then we're going to get 7/8 plus 1/16. So that's 14, so 15/16, and then I'm guessing this is going to be 31/32. So if I keep going, what am I doing? I'm getting closer and closer and closer to 1. If you graph this, you would see that. So although this series is infinite, the sum is, honestly, I'm not even sure what I wanted to put in this blank, but we know the sum, I'm going to say, does exist. We can find a sum, and we can find a sum using this little formula right here. But remember, I can only do, if r is less than 1, in the terms get smaller and smaller, so the sum of the series converges, we say. So if there is a sum, it converges. All right, and the sum of such an infinite series exists. If r is greater than 1, or the absolute value, it could be a negative r, then the infinite series does not converge, and we say it diverges. So let's use this little formula we have up here to see what happens with this series. S equals a sub 1, so that's a half, and it's divided by 1 minus, well, what is our ratio? I got to do 1/2 divided by, 1/4 divided by 1/2, which is 1/4 times 2, so it's a half. So what I get here is 1/2 divided by 1/2, which does equal 1, like I told you just a minute ago. So this is another little formula you need to remember, because guess what? Your calculator, you can't put this, if you got an infinite series, you cannot put that into your calculator and get it to do it for you. So I think we may have another example or two back here. Let's see what we have here. Find the sum. So oh, this is infinite. Right here, I can see it's definitely infinite. What do I want to check? Remember, I got to check the value of r and make sure it's less than 1. This is 1/10, so it definitely is. So I know that I can find a sum. The first term is 2. The ratio is 0.1. So I'm going to use my little formula that says S is a sub 1 over 1 minus r. So it's 2 over 1 minus 0.1. I'm actually going to rewrite that as 1/10. That way I can do it better as a fraction. So that's 2 over 9/10, right? Which is 2 times 10/9, which is 20/9. And if I were to put that in decimal form, which is what I would want to do since my R term is given to me as a decimal, let's see, it's 2.22 and the 2 just keeps on going. So we'll just round it off right there. So I do get a sum when my R value, or the absolute value of it, is less than 1. All right, let's see. We got 12. Let's see what R is. R is 4 divided by 12, so R is a third. So I can get a sum. So S is A sub 1 divided by 1 minus R. So S is going to be 12 divided by 2/3, which is 12 times 3/2, which is going to give me 18. So the sum of that infinite series actually is 18. And that is all we're going to do for this lesson. I meant to delete this, failed to do so. I think it is not in your notes packet though, so don't worry about that. And that wraps up our entire unit on sequences and series.